Welcome. Today we'll be learning about the contemporary practice of the current divider rule. As we have previously used the voltage divider rule for finding the voltage across a resistor within a series circuit, the current divider rule will allow us to find the current through a resistor in a parallel circuit. There are three key points when dealing with the current divider rule. For two parallel elements of equal value, the current will divide equally. For two parallel elements with different values, the smaller the resistance, the greater is the share of input current. For parallel elements of different values, the current will split with a ratio equal to the inverse of the resistive values. The following example explains this concept without any calculation being used. As shown in this figure, the current value of 9 amps is splitting across three parallel resistors. From inspection, we can see that the majority of the current will pass through the smallest resistor of 10 ohms, while the least will pass through the 1000 ohm resistor. Now, as the above example explains how to find a relative magnitude, it doesn't provide the definite magnitude. To find this result, we will need to use the current divider rule. Looking at this example, as we know the total current I splits between the n parallel resistors and then comes back out of the same value, the parallel combination of resistors has been replaced with a single resistor equal to the total resistance. Since the voltage V is the same across parallel elements, the following is correct. V equals I1 times R1, which equals I2 times R2, equals I3 times R3, which equals IX times RX. The product IX-RX refers to any combination in the series. Substituting for V in the above equation for IT, we have IT equals the value of current we are trying to find times the resistor of the element we are finding divided by the total resistance. Solving for Ix, the final result gives us the current divider rule, which states that the current through any branch of a parallel resistive network is equal to the total resistance of the parallel network divided by the resistance of the resistor of interest and multiplied by the total current entering the parallel configuration. Time for an example. The question asks, determine current I1 using the current divider rule. To start this question, we need to find the total resistance, which we find to be 873.01 ohms. Using the current divider rule, we sub in our values and we get a final answer of 10.48 milliamps.